Welcome to Mathema by RC YouTube channel. Today, this is our third class of class 9, that is in number system, in chapter number system. In this previous two class we discusses different type of numbers, that is the natural number, the set of natural number, the whole number, and the integer capital Z, the rational number Q, and also the real number. Okay, so all these numbers are represent in a number line. That means here we represent this number line. Suppose 0, 1, 2, 3, 4, 5 and dot dot dot, and in the left hand side -1, -2, -3, -4 and dot 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 in this part. And also we discuss and we also denote that in between 1 and 2 there are different kind of numbers. Okay, suppose 1.1, 1.2, 1.3 and dot 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 1.9, 1.9 and then 2 in decimal representation. There is point, that means in decimal representation this is. And also in 1.1 and 1.2 we also get suppose a different type of number. In between 1.1 and 1.2 we get 1.11, 1.12, 1.13 and dot 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 1.19 and then 1.20. Okay, 2 or 20. So we get in between 1 and 2. So in between 1 and 2 we get infinite number of numbers, the infinite number of real numbers. Okay, but all these real numbers, not only the rational number or integer or whole number or rational number. Here we get 1 and 2 are the natural number, are the whole number, are the integer, but 1.1, 1.2, 1.3, 1.9, these are not the integer or whole number or natural number. These are our rational number. That means in P by Q we represent these numbers in P by Q, where PQ independently, where PQ belongs to integer and Q not equal to 0. This is the condition of being rational number. But some numbers are not represent in P by Q form. Suppose in root over case, root 2, root 3, root 5, root 7, okay, dot 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 different kind of numbers. Suppose some numbers in 1.01, 0.1, 0.111, 0.111, 0.1111 and dot dot dot. This number also in between 1.1 and 2, in between 1 and 2, and these numbers cannot represent in P by Q form. In P by Q form, where PQ are integers and Q not equal to 0. So these numbers are called the irrational number. Irrational number. That means when some numbers, some real numbers cannot represent in P by Q form, these numbers is called irrational numbers. And the invention of irrational numbers, that is the great mathematician, this is here we can see the pictures of Pythagoras. Okay, Pythagoras in Greece, the mathematician, first famous mathematician and philosopher, first discovered the numbers which are not rational numbers, that means irrational numbers, in around 400 BC, before Christ. Many previous days, suppose in 2400 years before. So these numbers are called irrational numbers because we cannot retain this form in ratio of integers, that means in p by q form. So these numbers is called the irrational number. Here we get in representation, here we get that the root 2 is an irrational number for disclosing the secret root 2 to people outside the secret of Pythagorean set. Okay, now in this in this part we also say that all the numbers, that means all the numbers, that means here we get real number equal to rational number plus irrational number. Okay, here we get rational number and irrational number. So the rational number, where we represent these numbers in p by q, where pq belongs to integer and q not equal to 0, and in this irrational number, we cannot represent p by q form, where pq belongs to z and q not equal to 0. These are the condition of the representation in integers. Okay, so all the rational and irrational number, that means real number, we represent in this number line. Okay, in this number line, where 0, here we get 1, 2, 3, that means the positive numbers, and in this left hand side, minus 1, minus 2, minus 3, minus 4, that means in this left hand side, this is a negative number. So the real number and the number line, this is called the number line. So the real number and the number line are the relationship between real number and the number line. So all the numbers we can represent in a number line. Also, if we find any number in number line, this is a real number. So the relationship of number line and real number we get, and theorem, this is called the Cantor Dedekind axioms. Okay, Cantor, that means the mathematician G. Cantor and the mathematician R. Dedekind represents in 1870. Okay, two German mathematicians Cantor and Dedekind showed that corresponding to every real number there is a point on the real number line. Okay, corresponding to every point on the number line there exists a unique real number. So there is we get Cantor Dedekind axioms or Cantor Dedekind's theorem in 1870. We get that in each real number we can represent in number line. Also in number line, if a number in any position, we get any real line. Okay, so corresponding to every real number there is a point on the real number line, or corresponding to every point on the number line, there exists a unique real number. Okay, so in this class we discuss two parts. One is irrational number, the invention of irrational number. The mathematician Pythagoras in Greece discover this irrational number, the concept of irrational number, and fulfill the real number, that means rational number and irrational number. Also we get the relationship between real number and the number line, that means the Cantor Dedekind axiom. Thank you for this class. In this next class we also discuss different kind of number system related problem and mathematics. So subscribe this channel and tick the bell icon, and also go to the description box and join Telegram group. There is a Telegram group link. Thank you so much.